Hey everyone, and welcome to another exciting lesson in Rust. Now, we've learned a lot of things so far, and today we're going to learn about errors and error handling. I know it's exciting, error handling is what you want to know, but Rust ensures that you can't get a null value. But how does it do that? How do you return something that's optional or could fail? Well, they have some really nice built-in things that not only lets you return optional things, but it also lets you return an error if you like, but it doesn't give you the whole nasty try-catch and things like that. Obviously, I'm a little biased, but I really like it. So let's jump in. Now, I have made a couple functions here that I want to show with you. So this one is getting an optional. This is just a demonstration, and all this code is out there for you to go get, so check the link out down below and you can review all of this yourself. Now, this is a function that returns an optional. There is this optional, and now it's an enum, and we're going to learn more about enums later, but it's an enum. And enums are very close to being one of the next lessons. So, yeah, it's an enum. And it optionally returns an I32. Now, if this is a very simple function, if I is greater than 5, we return something, but if it's less than 5, we return none. Now, you might be thinking, well, Merrick, if it's none is just another word for null, that's not true. And you're going to see that in a little bit because it's going to force us to use this. Let's go ahead and do it right now. Let our optional equal get optional of 6. Now, you and I know that this will actually return some value, but Rust doesn't know, probably. So if we try to go and use opt, let's see what it is. Opt is an option I32. It means we can't actually access the I32 directly. What a lot of people will have you do, and what I'm going to encourage you to never do, is they'll do this. They'll say, let I equal opt.unwrap. Unwrap is this special function that is going to get your value for you. It's going to take this and give you an I32. You can see this. It's an I32. Let's see how this goes. This ran. But let's actually print this out to make sure it's working. Print line, I equals this I. All right, this should give us, this should just print it out for us. Let's go ahead and run it again. All right, I is 6. Everything's working great. Now watch this. Are you ready? This is why you never use unwrap. Unwrap is asking to have a panic. It means you're not handling something you could be handling. This is bad. This is just bad. Let's actually handle it. Let's do it like it's supposed to. There's a lot of ways to handle it. I'm going to show you a couple. Really, the easiest way is to just use a match or a if statement. So let's do those. Let's use an if statement first. There's 2 ways to do this. We're going to do an if let and then an if else. So let's do the first if let first. If let sum I equals opt, then we can go ahead and do our print line in here. So all this is doing is it's doing a let, and it's saying if there is something, if something of I is equal to this, then we go ahead and do it. Now watch this. Our code's going to run. Now it didn't print a line because this didn't run because we wrapped it in a safe handleage. So let's make sure this works. 7. Now look, it printed out 7 because it could work. Now this is great, but it actually incurs some nesting. And as in the last episode, you can do it just like the let else as well. So we can do if let sum I opt else. Oops, no if. There we go. Now you're gonna see this says it doesn't diverge. And basically what it means is if you're using this, you have to make it diverge. You can't actually have I after this block. That means it has to return So we'll just print something and then return. We're just going to return with an OK as well. But let's go ahead and we can't print I in here because I's not actually in this scope. It's in the scope out here. So we can actually take this, put this down here, and we'll just put this as a double I because this is the second time it prints from this one. All right, and we'll just put in here that I was none. There we go. And we'll put a little semicolon there, and we're ready to run. Now, with 7, we'd expect it to print twice. Once here, and then once here, right? Let's do it. We got exactly what we wanted. And now, if we do it with 2, we'd expect this to run and this to run, and then it's going to terminate here. So we'll never get I. I was none. So yeah, we wouldn't expect this to run at all. Super cool. So that's how it forces you, or mostly forces you, to handle optional values. Now, another way you can do it is with the match case. So let's do that really quickly. Cool. You're going to see here missing arms, none, and some. Awesome. It already knows what it's looking for. So let's do those right now. We'll do none. And we'll just print I was none here. And we'll print this I was none from match. And then for sum of I, we're just going to do this, but we'll do it with 3 I's. I. Oh, I didn't copy very well. There we go. All right. So now we're doing it with a match. That's pretty fantastic. Do you see what happened here? This already had to return, so this never ran. That's awesome. This divergent path, I love this because it allows you to do early returns from a function. Let's move this up just to see it run. Now we can see we got the I was none from match. Super cool. Do you want to know what's really cool about this? Is it works just the same for result. Now, I recorded this in 2 steps because the first time through, I recorded with the anyhow library. And you know what? That was a mistake. I am now returning to do this using just the standard library because we're learning just the standard library. It was just habit because I really like how it solves a problem that you'll see eventually yourself. But you need to actually use the standard library to see why anyhow solves that elegantly. So anyhow, we'll get on to using the results from the standard library and understanding how Rust and the patterns Rust has to deal with it. All right, so here we see that we have this type of result. It's a type, it's a generic type that takes 2 different things. You can see here on this, it has 2 types, type T and type E. Now, it is interesting that it is an enum, but we'll get to how awesome enums are in Rust in a little bit. Now, this is the success type. This is the type that is returned if success. So this could be anything from your own custom type to an I32 to whatever you want. Now, if you don't want to return a type and just want the result part, the error part, you have a function that can error, but you don't necessarily want to return anything, this is just an empty type. This is saying we don't have a return type, just an empty type. Nothing here. And if you're wondering why this is a box dynamic error, again, we'll get more into this, but really quickly, error is a trait. In many other languages, this would be considered a interface, which means it doesn't have a size in memory. And per Rust's mandate, everything has to have a known size at compile time. And box just wraps these traits so that they have a known size and it stores a reference to that size. So this dynamic is just a way of you saying, yes, I know that error is a trait type. That's all it's doing. So that's what this is what the signature of result looks like. You can see down here, this is the exact same signature right here. You can see I have a result of I32 and I spell out exactly where this error trait comes from. It comes from the standard library in the error package module. Okay, so I made this function and let's use it. We'll talk more about what the function does on the inside. Basically, all it does is it requests you to pick a number, and then it returns it. So let's use it, and it returns it as a result because guess what? We can get an error from this read line. Pretty cool. Let's use it. Let user input equal this. Pretty easy. Now, if we look and see what this is unused. So let's try using it. We're gonna just print it out. Now we get a red line. Why? Well, the thing is, this is returning a result. We can't actually use the string that was input immediately. If you check this out, you can see that the format strings result does not return or does not implement display. But this is interesting. This means that this is not really what we wanted. We want this string. We want the success type that is passed out from this. So how do we get to it? Now, we could always do the bad thing and call unwrap. But again, this could cause you to panic. Please don't do it. There's a lot of easier ways to get this information than doing this. So let's figure out another way. Well, the simple answer is you can do it just the exact same way as optionals. Optionals, you use some and none. And with error types, it's okay and error. So let's do that now. Let okay, we'll call it S for the string, equal user input, else we're just going to return. We'll just return okay for right now because we haven't implemented our own error type yet, so I don't know what type of error we would return here. But we can return an error here, and we will work on doing that in just a little. We can now use S outside of this statement. Now remember, this let, you can't use S in here because S only exists after the branching logic, and this has to have branching just like the optional. Well, cool. Let's run this and see how it works. Please pick a number. Merrick. Input was Merrick. So our application ran, it worked perfectly fine, but we have a problem. This let Merrick be acceptable. That's not really acceptable. We want it to be an integer. So let's figure out if it's actually an integer. Let's change this to please pick an integer. All right, so let's parse this int and see how Rust handles that. Because parsing could be pretty unsafe. It might fail. Do you think it causes a panic? Let's try it. So let int equal s.parse. And here, instead of just calling the function, we're going to do something called a turbofish. We're going to do : I32 before the function call. So this right here, the turbofish here, is just telling it what we want to parse it into. We're just saying, hey, instead of this, which doesn't know what we're parsing to, so you get the red line, because it doesn't know what type to parse it into, this is how Rust tells it what to parse it into. All right, so that worked. But if we look at this, we see it's actually a result and a parse int error. So Rust is again protecting us and forcing us to unwrap this before we can actually use it. And as long as we don't use the unwrap keyword, we're completely safe. So how do we do this? Well, again, we can do the same thing as we do up here, and we can unwrap it with that, but let's unwrap it with a match just to get to practice it. Match on our int, and let's see. It's going to tell us we have 2 branches. Watch this. Missing match arm, okay, and error. Like I said, again, it's instead of some and none, it's okay and error. Okay, and that will have our I32 in it, and we'll just print a line that we'll just print it out. That's what we'll do. And on error, we only want ints. All right, so let's run this again and see how it works. Please pick an int, Merrick, input Merrick. We only want ints, please. This failed to parse. We consumed the error. We could have done something with error here, E, and done something with it, but that's really beyond what we need to do. We just wanted to parse it, so we're just gonna consume that error. Let's run it again and make sure it works with an actual integer. Please pick an int, We'll pick 32. I is 32. Now, there's a little bit of nuance here in case you're trying to do this yourself. Do notice that I trimmed this, and that's because when you read from the standard input, that the return when you press enter is actually a hidden character. It's white space. And so this will fail to parse if you don't call trim on it. Now, this honestly is a little bit verbose. This is a little verbose. There's a bunch of matches here. And really, basically, here, if this didn't parse, we just want to return with the error. We just want to propagate that error up. So does Rust have a good way to propagate an error if we don't want to deal with it here? Yeah, it does. It absolutely does. Instead of doing this, let's delete it. Say, let's make s just equal this. And instead of doing this here, we'll put a question mark there. The question mark after basically propagates the error up. As long as this returns a result with the same signature or something that it can go into, the question mark is going to unwrap it, and if it fails, it's going to return. So it's doing the exact same thing as this right here, where we just return, and we would have to return with an error, but it's just a question mark. Now look at this. It gets the user input and unwraps it, but on failure, it propagates the error upwards. Not only is it explicit, but it's easy. You don't have to write all of that. And we can do the same thing here as well. We can say let I equals this parse. And now, guess what? We can just print this I. And this will work the exact same way. You have now learned error handling in Rust. This is super powerful, super easy to use correctly, and if you're worried that it's going to be too much work to leverage, it's really not. It's just a question mark. That's all you have to do. It's easier than unwrap. All you have to do is make sure that you also return a result, which is generally a good idea anyhow. All right, so that is flow control and the second part of flow control. And I know that we have loops, which will be flow control part 3. But in the next episodes, we're going to go over structs and enums. There's a lot to talk about those. And so we're going to be covering those in the next lessons. After that, we're getting into a lot of the good stuff and or very soon to writing our own application since we have a ton of fundamentals under our belt. Thank you so much for joining me, and I hope that you have a fantastic day, and I'll see you in the next one.